Yasmin, and this video is my final project presentation for the Advanced Computer Programming course at Khalij University. In this project, I built a system called IoTGuard. The idea behind IoTGuard is pretty simple. Our homes and workplaces are full of smart devices, cameras, doorbells, sensors, etc., and most of them are not very secure. Once an attacker compromises even one of these devices, they can use it for things like DDoS attacks, port scanning, or moving deeper into the network. Traditional intrusion detection systems were designed for the classic IT networks, not for this kind of noisy, heterogeneous IoT traffic. So in this work, I focus on flow-based machine learning intrusion detection for IoT networks. I use a large IoT intrusion dataset from Kaggle. This is how it looks like. That contains more than 1 million labeled network flows with entropy and mutual information-based features. On top of this dataset, I compare several classical models of machine learning, including and not limited to the following: random forest, extra trees, logistic regression, decision trees, and Gaussian naive Bayes. And then I deploy the best one in a small practical system. The goal of the project is not only to train a good model, but also to integrate into something that could realistically run on a gateway. For that, I built a FastAPI backed backend that exposes and predicts endpoints, and some simple CRUD operations, and a web dashboard where an operator can send flow data, get a prediction in real time. This is our interface. And get a prediction in real time and review previous records. In the rest of this video, I'm going to walk through the dataset and methodology, show the architecture of the IoTGuard project, briefly discuss the model performance, especially why I chose the random forest as the final classifier, and then give a short live demo of the FastAPI backend and dashboard. So as you can see here, this is the Jupyter Notebook interface. I've used this one in order to deploy my machine learning models. As you can see here, I'm just showing a part of the dataset. The dataset itself contains 8 rows. In this, it contains 24 columns and around 148,000 rows. Firstly, after cleaning the data, I've started to deploy the first model and train it. First model I've started with was logistic regression, which gave the accuracy of 0.99. Secondly, the extra trees, which was with an accuracy of 0.98. And the random forest classifier with a 99.9, and the naive Bayes with the 99.3. Lastly, the decision tree with a 99.6. This is a small comparison table with all the accuracy, precision, and recall and F1 scores. The best model I've chosen for this specific project would be random forest. Now that I've chosen the best model, I've saved the model using that classifier, so I can then integrate it into my backend. Before that, I will show you a small example of the accuracy and using the confusion matrices. This is the confusion matrix for logistic regression. Then the confusion matrix of random forest, decision tree, and the naive Bayes. Lastly, the extra trees. This is a small comparison table again with all the necessary information of each model. Lastly, I've saved the model into a CSV file into my project folder. Then I've moved to the backend. The project structure here, I do have the backend file with the main and necessary other files and the main code. then another folder which is for the front end, where I used some HTML, CSS, and JavaScript in order to reach the final results. As you can see here, I've added middleware and the course middleware in order to connect the database that I've used, the model that I've saved with the front end. For now, let's test the APIs. We have the get root, the post for the prediction, and the records to get and the get for the records where it gets the records, a post for creating a new record, and a get for the getting the record by the ID, a put where we can update a record, and deleting a record. Let's test this in the front end. Let's add any random number and we will see what it predicts. Lastly, we will add a device name So the prediction result would be an attack since these high numbers are included, and the attack probability here as well is given with an 88.11%. If we go into this section where we can manage the records, we're able to refresh, create a new record, and also edit a specific record. Say like this. Record updated. Or we're able to delete a record as well. And that would be it. As you can see here, this is the big picture of how this system works. By collecting the IoT network traffic using the sensors, etc., and classify it into a normal or attack traffic, and then pre-process it and explore the dataset, clean it raw with CSI, handle the missing values, etc. Then we trained and evaluated on the labeled flows, and we compared between the machine learning models, choosing the best one. We trained and evaluated the labeled flows with 0 equal the normal and the 1 equals the attack. The matrices and accuracy, recall, etc., confusion matrices. And then once we're done with that, we can select the best model. And after that, we save it. We save the model and incorporate it into the IoTGuard dashboard with FastAPI, JavaScript, and then we check the log of flows and reusable for retraining. Other than that, we have extracted the features, categorical features, etc. And this is the end. After implementing the CRUD API with the get, post, put, and delete operations, and also after that it's incorporated into the dashboard as well. And this is the end.